pinged Mirsha, but in the meanwhile, maybe we can get started with a round of introductions since we have some new folks joining in. I'll begin with myself and then we can go around. I'm Kavya, I'm the product manager of the Salt Open team. I don't necessarily join into all the working group calls, but then I do manage and facilitate these calls, set them up, and I join once in a while to be aware of what's happening within each of the working groups and to understand if I can help in any ways. In case of networking working groups, SALT has been hoping to partner with some of the companies, and one of them that we are partnering with is Juniper. So today I have with me Tim. Tim, why don't you go ahead and introduce yourself?
Hey folks, my name's Tim Fayola. I'm an automation-focused resident engineer working for Juniper Networks. Code a lot in Python. I've used SaltStack a little bit in a personal lab, and I'm generally into just solving problems with coding and automation. So happy to be here. Thanks.
Thanks for joining us, Tim. And Zach, do you want to go ahead and introduce yourself?
Yeah, I'm Zach. I work at DigitalOcean as a network developer alongside Mircha.
That's great.
I can go ahead.
Yeah.
I'm Wayne Warner. I'm a core engineer on the open team here at SaltStack. I've been, I guess it's been about 9 months that I've been here working full time at SaltStack. There's a number of corners of Salt that I've haven't delved deep into yet, but I really enjoy networking in general and just kind of helping Salt to go fast. And as I believe we all know, networking is one of the slowest parts of the whole process end to end. So anything that we can do to make that go faster, I am all for.
Okay, thanks, Wayne. Tommy, do you want to introduce yourself? Maybe we'll then get going. So Wayne, did you have any backup agenda for today? I'm not sure if Mircha is able to join us.
Yeah, not either, but I do have, I guess, a few things to share. One of the main focuses of my time recently has been on our tests, and in particular, we were seeing as we were running our tests that we'd hit an SSH timeout issue where our if you're not familiar with how our tests are run, we use a tool called Kitchen and a plugin for that called Salt Kitchen that spins up EC2 instances, runs our test suite, and then tears down the EC2 instances. What we've been seeing is that it spins up, it starts running, and then at some point we end out with the network box completely unresponsive, or the network on the box completely unresponsive. We can't get in via a regular SSH connection. The Salt Kitchen does an SSH timeout. Even on EC2 in the AWS console, you can't get a screenshot, can't get system logs or anything, just the box appears to have hung. What we've also noted is that if we don't allow Kitchen to destroy the box, we can restart it, and then it will actually be responsive again. We can SSH in. One of the observations we've made in the past was that our logged into the box and watched the memory usage, and we saw that grow and grow and grow, and eventually the memory basically maxed out the memory available on the box, including the swap space, and that would coincide with the network unavailability. So we started looking into the memory allocation, but we weren't able to find anything. And then just recently, we discovered that did not seem to be, that seemed to be correlated and not causation. The network traffic we started putting some more aggressive memory monitoring. And despite still seeing the network drop out, it didn't appear to be related, at least to forking the processes, which is what our theory was. And then just recently, it appears to be independent of that. And I was seeing it, the network timeout happening regularly with a particular configuration. So I started putting some more aggressive memory monitoring, or some aggressive network monitoring on there, and checking IP tables, checking the IP adder for the interface. And when I started measuring it, the problem went away. So that's kind of where things are right now. It appears that we do have something that's causing some issues within our test suite for networking. If we can figure out exactly what's causing that, then we should be able to fix it. So that's kind of at least one of the major hurdles that I've been working on recently. I'm not aware of any other things that we've got going on the network front that would be super interesting. So that's what's been going on from our side of things. Anybody have any questions or thoughts or ideas they might have come across that could be helpful there? Or
and I'm sorry, that was Wayne speaking, right?
Yes.
Okay, hey, there's Tim. So that was just for SSH on, I'm sorry, and what? I missed the first part of that.
Yeah, so the way our test, automated test framework is set up, we've got Jenkins, which fires off Kitchen using our plugin Salt Kitchen. And so that creates a new instance on EC2, and then we'll SSH in, run some commands, and then get the results of the tests, reporting success or fail. Mm-hmm. What we've been seeing is that that process will time out. It'll be an SSH timeout, and Kitchen will never be able to reestablish a connection. We've also tried like SSH directly into the box, like not via Kitchen or anything, just command line SSH, and the box is unresponsive. So there's definitely something going on there that we have not been able to identify in our logs. We started using Elasticsearch, and if you're familiar with the file, there's a couple of tools that they have, file beats and metric beats and journal beats, I think, for just forwarding information from the box. And what we noticed as we started implementing that was that that communication failed with Elasticsearch. So we'd be trying to send information, but eventually it would just cut out, and that cutout would also coincide with the SSH timeout issues. So it's looking like something is happening on the box, and it's probably something happening in one of the tests. I know there are tests that are doing things with IP tables and other network, just other network tests that seem like they could be the cause of that, but it's not reliable when it fails, and it's not clear exactly why it's failing, typically because it just goes black and then we have no diagnostic information, because when we restart, everything's up. But as you know, IP tables, if you don't save it, then it just goes away when you restart. So we have a suspicion that something's happening there, but we don't have any solid evidence for that.
Gotcha.
Or against it, for that matter.
So Tim, I also wanted to check with you about, if you had, what was basically your motivation to be part of the networking working group as well? Were there some aspects you or Juniper in general was hoping to achieve through this partnership? Wanted to hear more about that.
Yeah, not necessarily. I was more joining to see what the group does, and if there's a way I can contribute to it. And I see a lot of value in the SALT platform. So if I can just get involved a little bit and see if I can help, that's my goal here.
Okay.
Awesome.
Yeah, that sounds perfect.
Do you have just a question from me? What are your areas of expertise / experience that you've dealt with in networking in the past, or is it just more
for my network engineering background, I've been in the networking world, net-eng kind of world since around 99. I have extensive experience in RSVP, traffic engineering. I wrote a book for Juniper on that around 7 years ago. I also have a lot of experience. I got my experience in automation through Junos Automation back in 2011 when on-box scripting was super rare and cool. So then recently I do have some experience in network modeling, understanding and modeling traffic failover. Okay. So I've also released an open source, just recently released an open source API set to create network models, of meshing networks where failover is not obvious. You can modify the model, modifying the topology, modifying the traffic, then fail something or fail multiple things. Understand how the traffic's going to fail over or the RSVP LSPs, stuff like that. So that's out there as well.
Cool. So something I wish we would have had in college. We did a project. I think it was in our InfoSec class, and we did our project was on mesh networks, and so one of the things we were trying to do was model how the network traffic might work in a mesh network, and yeah, of course this was college, so we didn't have much experience at all in many things, but we had a really interesting behavior in one of our models where it would end out with this vortex, basically, where the network traffic would end out circling the drain, as it were. And
really?
Yeah, it was really bizarre, but yeah. I don't remember much of the specifics other than that little one where it's we're trying to get the network traffic to you, but it ends out just circling round and round. It was pretty fun.
Nice.
Hey Tim, what's that project called? You said it was open sourced recently.
Yeah, it's called PyNTM, PyNTM. If you do a pip3 install PyNTM, it's also on just PyPy.
Oh, cool.
And it's also on GitHub as a repository as well.
Sounds kind of interesting. A few of the guys up there would be interested in that, I think.
And I'm happy to, help where I can with that. As far as like getting people started, there is an examples directory that has some example scripts that show you how to load a model and run a sim or multiple sims.
Neat.
So, Zach, I believe you're joining the call for the first time as well. So I had a similar question for you. What's basically your motivation to join this working group, as well as what's kind of like your area of expertise?
Yeah, I'm kind of started off in network engineering and sort of migrated over to the more developing side of things. I don't know, maybe 5 or 10 years ago. Like we've got a pretty large, well, I don't know if it's large, but we've got about 3,000 or so devices that are managed by Salt right now, mostly Juniper. And, we have some, I guess, a few pains with them. And sort of my motivation with this working group was maybe to surface what we're seeing, sort of the operational pains that we have with it, and kind of see if those can get talked about, addressed, whatever.
Okay. Sounds good.
Yeah. Well, since you bring it up, do you have kind of a high level of some of those pain points that you've been seeing?
Yeah, really the biggest one with me was whenever we so like I said, we manage mostly Juniper stuff, so we have to turn off the multiprocessing stuff whenever we configure our proxy minions. From what I've seen, that might lead to some memory leaks places. So like what we're doing is we're running on Kubernetes, and we basically have to, it's sort of an assumption that we will kill our proxy minions after maybe a week, maybe 3 days, something like that. So to me, that's, I don't know, it leads to some inconsistencies, right? So
Yes. Out of
yeah,
curiosity, are you using GitFS at all?
we are, yeah.
I'd be curious, and of course I have no clue what your system environment setup looks like, but I would be curious if it was possible to try it without using the GitFS. One of the things that we have noticed is that both of the libraries that we've historically used, Git Python and PyGit2, I think it is. From what I understand, we've had some conversations about this recently. They both use the underlying libgit, and it seems to be something with how they're using libgit that they're not properly freeing the memory, and that's led to issues. We have absolutely seen that with GitFS, things kind of go unfortunate. Like I think we've seen, going upwards of 8 or 10 gigabytes of memory, if it's available.
Yeah. So is this the master or the minions?
The master, I believe. I don't know about the minions, but the master definitely has exhibited that behavior.
Well, I mean, not to cut you off here, but
Yeah.
like we do see that sometimes on the master. It's
For
actually
your minions?
yeah. This was on the Minion
Oh,
side.
interesting. I don't think I have yet seen a minion memory leak, or at least I haven't heard of one. But that is very interesting.
Yeah, a long time ago, I spent a few weeks kind of digging into like maybe trying to figure out what was causing it. The best I can tell is that like whenever we do like high states or it's kind of interesting like whenever we enable the minion side scheduling, that makes the memory like really exacerbates the memory leak. I was taking a look at sort of like the threads that get spun up for that process, and like you give it like if I set a schedule for do a high state every 5 minutes, and I come back and look at it in an hour, like I've got 45 threads and the memory has just basically ballooned. So yeah, it may not be like I kind of figured it was maybe something with turning multiprocessing off and using threads. Like maybe something doesn't get cleaned up there like it does with multiprocessing, but that's just a hunch.
Yeah.
What proxy minions are you using by chance? This is Gareth, by the way.
We're using the Napalm Junos ones.
Okay.
And just as an interesting point of fact that I recently learned, because Python's, so when Python does when it spawns a new thread, it does do copyonwrite, but when you access memory in Python, when you access a variable, it's actually doing a write. And I forget exactly what the mechanics of it and why that was, but basically anytime you read memory in a thread, it is copying the memory. So it would make sense, especially, and I'm not sure how we're spawning new threads, but if we're spawning new threads and all the memory is being allocated in that main thread, then each time we spawn a new thread, it would end up getting a copy of all of that that main memory. And when it grows, it would just continue to grow, spawning off new threads. So it's very possible that might, well, it's almost certain that's at least a factor if it's not just the cause. I know there's been some work and some looking at kind of how we're spinning off threads and doing multiprocessing and forking, because we've noticed that there are some unfortunate historical choices that have been made. It's not from what we've seen, it's not really easy to just like clean all that stuff up and kind of really get it to operate the way we want it to. But but we have seen some places where we could definitely improve some things, and I know it's on our horizon maybe, but it's definitely something we're aware of and we'd love to get some time to address and fix, because it'd help a lot of things for a lot of people.
Yeah, I'm not too sure why we have to turn off multiprocessing really with because my assumption is that like if we didn't have to do that, like it would probably work. I think it has something to do with the SSH based proxies or.
That was my question. I wondered if you were using the SSH proxy minion, because I know the Paramiko library, which is what that uses, and I think the Napalm uses it behind the scenes. If it's SSH based, it does not support multiprocessing, and all sorts of bad things happen if you're trying to do it. But if the devices you're using are not SSH based, you might be able to just turn that back on, and that might solve your problems.
Yeah, I wish that was the case. As far as I know, I don't think like most of our stuff is Juniper stuff, so it's probably going to be SSH based unless there's something I'm missing there.
Yeah, I know we have our core team is getting together and doing an on-site here in a couple of weeks. So that's probably a topic that we'll try and address, at least bring up, is the whole multiprocessing threading, and to see if there's a way we can architect that a little bit better. Because we could make some progress there. I think that'd be a big win. And as you've seen, the way we're doing it now definitely is causing some issues for certain.
Yeah, I kind of feel like turning multiprocessing off is probably like a code path that is not well worn. So,
Yeah.
There may be dragons there. I kind of get, and I don't even know if it's related to the fact that we're not using multiprocessing. That's just kind of a hunch, really.
Yeah, I was just gonna ask if you knew why multiprocessing is turned off. Like if that's a.
Oh yeah, I think Gareth mentioned it. Like it's we sort of depend on napalm, and then napalm depends on ultimately Paramiko.
Okay. Yeah, that makes sense. Although, and this kind of goes back to that architecture comment. Is I'm very curious if it's just the way that we're handling spinning off kind of the workers. If we could do that in a better way to avoid the issue that we're seeing, I suspect that we could. I know I've done some things in the past, although I haven't done a lot with Paramiko, at least in that regards. But I would be surprised if we couldn't do something like if you're familiar with the reactor pattern, that basically just have the main Minion process handling the communication in and out from the master, and then spinning off a worker thread or multiprocess, and that multiprocess spins up the Paramiko connection, and then they just communicate via like a multiprocessing queue. I've done things like that, not necessarily with Paramiko, so I don't know if there are any caveats there, but I have done built projects like that in the past, and they've seemed to work quite well. So it's probably, that's something that would be worth looking into, I think, just to see if we could make that, less leaky, leaky good.
And then, like from what I understand, like caveats abound in Paramiko.
Yeah, I've recently been using some Paramiko locally. I have an EdgeX router at home, and I've been using Paramiko to connect with that. It's been interesting to see some of the pitfalls behind both SSH communication and how Paramiko works, and also my router, which when you save the communication, you got to make sure, or the configuration, somebody else is also making changes that could cause some issues. So
oh yeah, we run into that on occasion too.
Yeah, I've been seeing some learning some things very painfully, like when my configuration completely gets wiped out and I'm like, well, crap, and had to restart my router.
I think you touched on it maybe a little bit there too. Like I guess maybe one of my other pain points is like I said, like we're managing a few thousand devices, and I think like it's a little painful to turn up a proxy minion per device. Like there seems like there's a lot of overhead there that maybe isn't necessary. Like I don't know if using the reactor pattern that you talked about, like it's possible to do, one process that manages multiple devices. Or, something to keep our memory and like resource footprint a
lot lower,
a little bit less than what it is now. Yeah.
I don't know. Have you seen Marcha's?
The S proxy stuff.
Yeah, yeah, that
Yeah,
looked
yeah,
very
yeah.
interesting, and it sounds like it does. It will do a lot of that stuff. So I know we've definitely talked about and kind of started looking into the idea of incorporating that into Salt, which I think would basically solve that pain point for you and many other people dealing
Yeah,
with SSH-based network devices.
totally. Yeah, I think the like we can use it. Certainly, it has a use case in our network. I think the big drawback with that was that I guess you lose that persistent connection to
Yeah,
the device, and I guess it's a little more difficult or requires a little bit more thought whenever you're doing sort of event driven stuff.
yes.
But
Yeah,
there's definitely a use case for it on our network for certain devices, but I don't think it fits everything.
yeah, yeah. And definitely the reactor pattern could also be a positive, have a positive impact. Just kind of, I think it'd be helpful to think about some of these, I guess, just higher level workflows, and kind of consider what different uses people have. Because I know managing network devices is kind of a class far removed from managing always on servers. And things like that.
Yeah, no, I'm totally jealous of all the server guys.
Yeah.
They get all the cool toys that behave.
Yeah. Although I have to say that at least being able to SSH into a network device is so much nicer than some of the interfaces I've used in the past. JavaScript-based HTTP connections.
Yeah, no thanks.
Yeah. Yeah. Kavya, is there anything else that you've got that we should talk about or cover?
I think that's about it from my side.
Okay. Would it be helpful for us to put out some kind of survey, a little bit about what we just talked about, like what kind of, I guess, topology people have in the networking sphere? Like, we've got less than 1,000 minions, or less than 1,000 devices, or more than 1,000 devices, and kind of the frequency behind like how often do you make updates to those devices? Would that be a helpful survey to put out, so we just kind of get a bit of a feel for what problems people might be facing?
That would certainly be of great help to the product team. So
I think also including like types of devices would be helpful too. Like, to give us a good sense of like who's using particular models, particular how many people are using like SSH based using Salt to connect to their network devices using SSH. That would be a good metric to know.
Does anybody have any other ideas about like what metrics or information we might like to capture that would be helpful? So we talked about types of devices. Number of devices, topology, etc. Frequency of updates, the types of devices, number of devices, and topology, frequency of updates. Anything else? Okay. Kathy, is that something that that you would do, or would you like me to put together some kind of like survey on maybe Google Forms for that?
Yeah, I can work with you to put up a survey either through Google surveys or Typeform. Yeah, and I can publish them. I think, yeah, we can discuss it.
Okay, sounds good.
Okay.
Anything else that's come to mind in the last few minutes for anybody?
That's all I have.
Alrighty. I think we've got some good things to go off of here. Definitely looking forward to being able to make a lot of these improvements that we've talked about. I know many people will be much happier if they can get some of these features in play. But, I guess well, great day.
Cool.
Yeah.
Thanks, folks.